Hidden, the hidden war over rare earths. No one talks about this. Rare earths are not just minerals, they are the invisible foundation of modern military power. Electric vehicles, wind turbines, smartphones, missiles, drones, satellites, and semiconductor supply chains. The hidden war is not fought with tanks, it is fought through mining rights, refining capacity, export controls, and industrial subsidies. China is the central actor. It controls around 60% of mined magnet rare earth production and over 90% of refining and nearly 95% of permanent magnet production. According to IEA, that means the real choke point is not the only mine, it is processing, separation, metallurgy, and magnet manufacturing. Part 1. Why rare earths actually are. What rare earths actually are. Explaining that rare earths are a group of elements used in high performance magnets, batteries, screens, lasers, electronics, and defense systems. They are not always physically rare, but they are difficult, dirty, and expensive to process. Part 2. Why rare earths matter more than oil in some sectors. Oil powers movement, rare earths powers precision. No rare earth magnet means weaker EV motors, weaker wind turbines, weaker missile guidance systems, weaker drones, weaker radar, weaker robotics. Part 3. China's real power. Refining, not just mining. The mistake most people make is thinking that it is about who owns the rocks. Wrong. The real empire is in chemical separation, refining, alloy making, and magnet production. Part 4. The military dimension. Rare earths are embedded in fighter jets, submarines, guided missiles, radars, satellites, drones, and electronic warfare systems. This is why the Pentagon is backing non Chinese rare earth supply chains, including projects involving Lineas, MP materials, and others. Part 5. China's export control weapon. In 2025, China tightened rare earth export controls, especially on heavy rare earths and related compounds. USGC notes April 2025 controls and later October expansion, with some October measures suspended for 1 year in November 2025. Part 1. What rare earths actually are. The term is misleading by design. Rare earths are not rare in the way oil is scarce or diamonds are controlled. The deception begins with the name itself. These elements, such as neodymium or dysprosium or praseodymium or yttrium, exist in Earth's crust in moderate quantities. The constraint is not geological availability, the constraint is extraction complexity, chemical separation difficulty, and industrial processing capacity. There are 17 elements classified as rare earth minerals REEs. They sit in the lanthanide series, plus scandium and yttrium. On paper, they look like obscure entities in the periodic table. In practice, they're embedded into the most advanced technological systems currently in existence. The first failure point is not analysis, most analysis is conceptual. People assume value comes from scarcity. In this domain, value comes from processing difficulty, industrial specialization. The real bottleneck, separation, not mining. Rare earths do not exist in concentrated, easily extractable forms. They are chemically similar, often mixed together in ores and bustnasite, and monazite. Extracting them involves multi-stage chemical process involving acids, solvents, and highly specialized industrial infrastructure. This is where most countries collapse. Mining is straightforward, capital deployment. Processing is accumulated industrial knowledge. You can buy machines. You cannot instantly replicate decades of chemical engineering expertise and supply chain integration. This is why countries with deposits still remain dependent. They extract raw materials, then ship it often to China for refinement. At that moment, they lose leverage. Functional role. Why these elements matter. Rare earths are not substitutes. Their atomic properties, especially magnetic, lumis- luminescent, and catalytic behavior, are difficult to replicate. Neodymium and dysprosium enable high strength permanent magnets. These magnets are critical because they allow machines to be smaller, lighter, and more efficient. That matters in every system where energy efficiency and precision are non negotiable. Remove rare earth magnets and you degrade performance across sectors. Electric motors become bulkier and less efficient. Wind turbines lose output efficiency. Missile guided systems lose precision. Drone loses their endurance. Consumer electronics loses compactness. This is not incremental degradation, it is structural weakening, the illusion of substitution. There is ongoing research into alternatives, ferrite magnets, induction motors, and others material sciences. The reality is that substitutes exist, but they come with performance penalties. In high stakes environment, military systems, aerospace, advanced robotics, those penalties are unacceptable. This creates a strategic trap. You are technically not dependent, but practically you are. The environmental constraint. Rare earth processing is environmentally destructive. Toxic waste, radioactive byproducts, and chemical runoff are standard byproducts of separation. Western economics made a calculated decision decades ago, outsourcing this damage. China made the opposite decision, absorb environmental costs in exchange for industrial dominance. That decision now compounds into strategic leverage. Countries attempting to rebuild rare earth supply chains face a predictable obstacle: domestic resistance, environmental regulations, public opposition, and regulatory delays slow down development timelines. This is not a technical problem, it is a political and social constraint. Structural reality. You are not dealing with a commodity market, you are dealing with a controlled industrial ecosystem. The chain looks like this: mining, concentration, separation, refining, alloy production, magnet manufacturing, integration into end products. Most countries operate at stage 1. China dominates at stage 3 through 6. Let me repeat the stages once again. The chain looks like stage 1 mining, stage 2 concentration, stage 3 separation, stage 4 refining, stage 5 alloy production, stage 6 manufacturing, magnet manufacturing, stage 7 integration into end products. Control over intermediate stages is what defines power, not ownership of raw materials. Strategic implications. If the supply chain depends on another nation's processing infrastructure, then the controlling of industry or the control of the domestic industries industrial base the control of the domestic country's industrial base is also handed over to that country. This is the actual definition of rare earth problem. Part 2. Why rare earth matters more than oil in certain sectors. The strategic miscalculation, comparing everything to oil. Oil controls energy flows. Rare earth controls energy efficiency, precision, and system intelligence. In 20th century warfare and industry, oil scarcity crippled movement. In 21st century, rare earth scarcity degrades performance quality, which is more decisive in modern conflict and high-tech economies. A jet that flies isn't enough. It must outmaneuver, outdetect, out-target. That performance gap is where rare earths operate. Precision is the new battlefield. Modern systems are no longer brute force systems, they're precision dependent systems. Rare earths enable miniaturization, smaller, lighter components, energy density, more output per unit, thermal resistance critical for high speed systems, magnetic strength, core to motors and sensors. Remove rare earths and the system still function but at degraded levels. That degradation compounds across systems. A missile that is 5% less accurate is not slightly worse. It fails mission objectives. Electric vehicles efficiency as competitive weapon. Electric vehicles are not constrained by fuel logistics. They are constrained by motor efficiency and battery integration. Neo Neodymium based permanent magnet motor delivers high torque to weight ratio, better efficiency at lower speed, longer range per charge. Without these magnets, manufacturers revert to induction motors or alternative designs. These are viable but heavier, less efficient, and strategically inferior. Mass adoption. This means rare earth control leads to ultimate control over EV cost, which controls performance curves, which also controls global automotive transformation. Wind power, the illusion of energy independence. Let's talk about wind energy. Wind turbines depend on rare earth magnets as well for direct drive systems. Without them, gearboxes become necessary, maintenance cost rises, efficiency drops, lifespan decreases. When we think we are building renewable energy independence, in reality, we are shifting dependency from oil exporters to rare earth processors. We are not eliminating dependency, we change its location. Military systems, where margins decide outcomes. Rare earths are embedded in radar systems, sonar systems, electronic warfare platforms, satellite communications, laser targeting systems, precision guided munitions. These are not optimal, and these are not optional components. There are the difference between detection and invisibility, hit and miss, survive and loss. The, the military implication is simple. If supply is disrupted, you don't stop producing weapons, you produce inferior weapons. And inferior weapons lose against superior ones, even at equal scale. The hidden multiplier effect. Rare earths operate as a force multiplier. They do not create capacity from nothing. They amplify existing systems. This means strong economies become stronger, advanced militaries become more dominant, technological leaders extend their lead. Conversely, weak supply chains collapse faster, late adopters fail further behind. This creates divergence, not convergence. Correction, supply chain leverage versus consumption volume. Oil power comes from volume consumption. Whoever consumes more is vulnerable. Rare earth power comes from processing concentration. You don't need to control the entire supply chain, you need to control the critical stages. That's the asymmetry. Oil leverage is diluted across many producers. Rare earth leverage is concentrated in few processors. This makes rare earth a more precise geopolitical weapon. Time lag advantage. Oil shocks are immediate, price spikes, market reaction. Rare earth disruptions are slower but more damaging. Production delays, component shortages, manufacturing bottlenecks, as well as strategic project delays. By the time the impact is visible, the damage is already embedded in supply chains. This delays this delay reduces reaction capability. Strategic reality. Oil determines whether your economy runs. Rare earth determines how well it runs. In a world driven by AI, automation, robotics, electrification, and advanced warfare, performance matters more than existence. Mining is low complexity, heavy capital, and globally replicable. Countries like the United States, Australia, and Canada all have rare earth deposits. That doesn't translate into power. Power sits in refining and downstream processing. This is where China dominates with near monopoly conditions. The industrial stack that automatically matters. The rare earth chain is layered. Most actors stop at the first layer, mining. Let's talk about the layers once again. Mining, ore extraction. Step 2, concentration, initial separation. Step 3, chemical separation, individual element isolation. Step 4, refining, which means purifying it to usable forms. Step 5, metallization and alloying. Step 6, magnet manufacturing. Western countries operate inconsistently at stages 1 and 2. China operates at scales across 3 to 6. Mining without processing is dependency disguised as ownership. Why? Refining is the real barrier. Rare earth elements are actually similar. Separating them requires multi-stage solvent extraction, repeated hundreds of times across complex chemical systems. This is not plug and play industrialization. It requires decades of process optimization, specialized chemical engineering expertise, large scale and low margin industrial tolerance, environmental trade offs. China invested early, aggressively, and without regulatory hesitation. The West did not. Now the gap is structural. Environmental costs as strategic weapon. Refining rare earth produces toxic waste and radioactive byproducts. Western economies avoid this cost. China absorbs it. This wasn't accidental, it was a long term trade off. Short term environmental damage substituted by long term geopolitical leverage. Now, when Western countries attempt to build refining capacity, they face environmental opposition, regulatory delays, high compliance cost, as well as political resistance. When a competitor emerges, China floods the market, prices collapse, foreign producers become unprofitable, projects shut down. China dominates this stage as well. This creates a layered choke point. Raw material China, refining material China, finished magnets China. Breaking one layer doesn't break dependency. You need the entire stack. Supply chain dependency is engineered. Western industries, automotive, defense, electronics depend on stable supply chains. China doesn't need to cut supply completely. It only needs to delay shipments, restrict certain elements like heavy rare earth, introduce licensing requirements, create uncertainty. Uncertainty alone is enough to disrupt production planning, inventory management, capacity investment decision. China's dominance isn't accidental, it is the result of early industrial policies, state backed subsidies, environmental tolerance, and long term planning. Modern military dominance is determined by subsystems quality, sensors, guidance, proportional efficiency, electronic warfare, resilience. Rare earth elements sit inside these subsystems. Remove them, and your advanced military becomes a downgraded version of itself. The platform still exists, the performance advantage disappears. Rare earth as embedded capability. Rare earths are not standalone inputs, they are embedded across critical systems. Neodymium, dysprosium, high performance motors, drones, actuators, control systems. Samarium cobalt, heat resistance magnets, missile systems, aerospace. Yttrium, Europium, terbium, displays, targeting systems, night vision, lanthanum, optical systems, sensors. They are not interchangeable. Each element supports a specific operational function. You don't substitute them without losing capability. Precision, weapons dependence. Precision guided munitions rely on miniatured electronics, high guidance system, high efficiency control mechanisms. Rare earth magnets and minerals enable smaller actuators, faster response times, better trajectory correction. Without them, guidance systems degrade, increased missile radius, reduced reliability, higher resource expenditure per target. This increases cost per kill and reduces battlefield efficiency. Rare earth support these functions indirectly through components and materials used in single generation and processing. Electronic warfare system is also dependent on high performance components to jam enemy signals, protect own communication, detect stealth targets. A degradation here means reduced detection range, increased vulnerability, slower response cycle. In modern conflict, information dominance precedes physical dominance. Drones, the scale warfare platform. Drones are the most scalable military asset today. Their effectiveness depends on lightweight motors, high energy efficiency, long endurance, precision navigation. Rare earths are central to achieving these characteristics. Without them, fighting time decays, payload capacity drops, maneuverability weakens. At scale, this compounds into strategic disadvantage. Naval systems and subsystems warfare, starting from sonar systems, quiet propulsion, electronic detection systems, submarines and naval platforms rely heavily on these. Rare earths contribute to acoustic sensitivity, signal processing, efficient motor systems. Subsurface warfare is not about detection before detecting. If the systems are inferior, you get detected first. In that domain, being detected first is equivalent to losing. Supply chain disruption scenario. The entire failure scenario is not total cutoff. That's naive. More realistic. Export licensing delays, restrictions for heavy earth materials, critical for high temperature systems, as well as selective supply limitations. It can maintain leverage over key inputs, influence adversary production cycles, increase uncertainty in defense planning. The hidden constraint on military expansion. We can allocate more budget, we can increase procurement and procurement orders, but if supply chains are constrained, output doesn't scale, costs increase, timelines extend, and nothing concrete gets built up. Assuming a full export ban in a full export ban in crude, it triggers retaliation, accelerates decoupling, destroys long-term leverage. The more effective method is controlled friction, slowing, filtering, licensing, and selective restrictions. China has repeatedly demonstrated this approach. Export controls are calibrated, not absolute. The objective is not to stop supply. The objective is to control the tempo of supply. Mechanism, licensing, only not prohibition. Instead of banning exports outright, authorities impose export licensing requirements, end use verification, restrictions on specific elements, especially heavy rare earths like terbium and dysprosium, administrative delays. This creates uncertainty in procurement, volatility in delivery times, increased compliance costs. China doesn't need to intervene continuously. The threat of intervention reshapes the entire behavioral system. But the long term result was not independence, it was partial diversification with continued independence. The signal was clear. Supply can be weaponized. That signal will influence decision making today.